Hello everyone, hope all you are doing well. So today we'll learn about structural isomer. In my earlier lecture I have discussed there about hydrocarbon in case of chain, but today those carbon I will arrange in the form of branch. Okay, so actually today we are going to discuss structural isomer. So what is structural isomer? I mean compounds having same molecular formula but different in structure and chemical properties, that is called as structural isomer. Okay, now you see, if I arrange carbon in a chain, it is not considered as a branch. So if I add here one carbon, now it is considered as a branch. Are you getting my point? If I add here one carbon, or if I add like that, then also it is called it as a branch. Okay, instead of putting the carbon in middle, if I place here like that, this is not considered as a branch. It is considered as a chain. It is considered as a what? Chain. So to draw the branch of a carbon, you cannot add carbon in the terminal portion. Except that terminal portion, if you place somewhere in the middle of this terminal portion, if you place the carbon, it is called it as a branch. Okay, now let me check for the alkane first. Okay, the first member of alkane is what? Methane, then it is ethane, then it is propane, then we will get butane, and like that it will go on. So if I will try to draw the structural isomer, then I can draw from the butane only. I can draw from the what? Butane only. Because from propane, with propane you cannot draw. See, in propane 3 carbon is there. So if you just rub one carbon here, if you add it here one carbon, it is not called it as a branch. It is called it as a chain. It is called it as a chain. Okay. So that means from butane, I can draw the structural isomer. Now, when I will arrange carbon in a chain, I will arrange carbon in a chain. Okay, this structure is called what? This structure is called N-butane. N-butane, where carbon number 1, 2, 3, 4 carbon is there, and hydrogen 6 and 2, 4. 10 hydrogen is there. That means the molecular formula of N-butane is C4H10. So this is one structure I can draw with butane. Next, let's see. Okay. So now I have put it here 3 carbon. If I place here 1 carbon, now it is called branch. The structure will be changed. Now here hardly 3 carbon. Here already 3 bond is there. 1 hydrogen I can place. Here 3 hydrogen. Here 3 hydrogen. Now you see the formula of methane is CH4. If 1 hydrogen will be less, it is called methyl group, alkyl group. That means this is called methyl. Okay, and this is called methane. Now you see, in branch, when you will get CH3, okay, that is called methyl. This is called actually substituent. Okay, this is called methyl group. This is called what group? CH3. It is called methyl group. Now, this methyl group is at what position of, in a carbon chain? See, this is the number first carbon, second carbon, third carbon. If I count from left to right, then also this methyl group falls in a second position. If I count from right to left, then also this methyl will falls under second position. Now the chemical name of this structure will be 2-methyl in a straight chain. This is called parent chain. Okay, longest chain in a carbon is called as parent chain, or straight chain. So in a parent chain, okay, how many carbon is there? 1, 2, 3. For 3 carbon, to whom we call propane, P-R-O-P, A-N-E. Because we are talking about alkane, that is why A-N there will be. Since in a parent chain there is 3 carbon, that is why it is called as propane. Okay. So with butane, with what? Butane, I can draw two structural isomers. One is N-butane, another is 2-methyl propane. So in 2-methyl propane, their total number of carbon is what? 4, and hydrogen is how much? 10. Okay. In N-butane also carbon 4, hydrogen 10. That means molecular formula of N-butane and this is 2-methyl propane, it is same, but structure is different and chemical properties are different, and these are called structural isomer. Okay, so with butane I can draw hardly two structural isomers. Now let me check for pentane. Formula C5H12. So first structural isomer of pentane will be N-pentane, where all the carbon are arranged in a what? Linear fashion. 1, 2, 3, 4, 5. This is called N-pentane. Okay. The second one, see, 1 carbon, 2, 3, 4. If I place here 1 carbon, okay, now it is branched, you see. This is the methyl group. If you count from this side, from left to right, the methyl falls under where? Second position. If you count from right to left, the methyl falls under the what? Third position. So which one we need to choose? We need to choose the lowest one. We'll cancel it. That means 1, 2. From left to right, if I count, the methyl falls under second position. From right to left, if I count 1, 2, 3. That means I cannot choose this one. I have to choose lowest one. So numbering of carbon I should do from the lowest possibility. So the methyl falls under the second position. So the name of this structure, chemical name of the structure will be 2-methyl. In a parent chain, how many carbon is there? 1, 2, 3, 4. So for 4, but, no? Since all are alkanes, so N. So butane, 2-methyl butane. The chemical name of this structure is 2-methyl butane. Okay. Now, can you draw more structural isomer? Yes, we can draw. Okay, let me rub this one. You just have a screenshot. Okay. Yes, let me rub this one. Then try next. See, 1, 2, 3. Okay, so if I add here 1 carbon, this now will be methyl group. This is the branch, this is the methyl group. Okay, see, now numbering of carbon, if you go from left to right, then also both the methyl group falls under second position. If I count from right to left, then also both the methyls fall under the second position. Okay, so here you see how many methyl is there? 2 methyl is there. So both the methyl are at what position? Second position. Okay, the first, second is the third. Okay, so the chemical name of this structure is 2, 2, because one methyl is second position, another methyl is also there, that is also in second position. So 2, 2, since there is 2 methyl, I have to write dimethyl. In a parent chain, how many carbon is there? 1, 2, 3. So for 3, to whom we call pro. Since everywhere there is single bond, that means alkane. So propane. So 2, 2 dimethyl propane. So hardly 3 structural isomer we can draw from the pentane. Okay, so have a screenshot. Okay, let me rub it. So now let's check for hexane. Okay, formula C6H14. So when if you arrange the carbon in a linear fashion, okay, that name is called an hexane. This is the one structural isomer. Number second, okay, 1, 2, 3, 4, 5. If I put here one carbon, okay, this also branch. This is the methyl group CH3. Okay, now I have to count the what carbon. I have to give numbering of this methyl group. See, first, second. If I go from left to right, okay, the methyl falls under the second position. If I count from right to left, it will falls under fourth position, and longest one will not choose. We will always choose the lowest one. That means it will be what, 2 methyl 2 methyl in a parent chain. How many carbon is there? 5. So it is pentane. Am I clear to you? Okay, now let's see, can we draw more structural isomer from hexane? See, 1, 2, 3, 4, 5. Okay, now if you add here one carbon, suppose if you add here one carbon, the chemical name will be the same, 2 methyl pentane. Will count from right to left to, I mean, give their priority to the lowest one. So 1, 2, I mean this methyl will fall under the second position. That means this and this, I mean same. So here I cannot place. So here I can place one carbon. If I place it here, now this methyl group CH3 falls under the what, third carbon in a carbon chain. If you go from left to right, if you come from right to left, you will get in the third position. That means the chemical name of this compound is 3, because the methyl is at third position of this carbon chain. So 3 methyl in a parent chain, 5 carbon, so pentane. Okay, so till now how many structural isomer we get? 1, 2, 3. Now let's check for next. See, if you arrange the carbon in this way, 4 carbon is there, 1 carbon if I add here, 1 carbon if I add here, 6 carbon. Okay, now you see, this is the methyl group CH3, this is the methyl group. Now you do the numbering, 1, 2, 3, 4. If you count from that side, 1, 2, 3, 4. Okay, so if you count from left to right, then also this methyl fall under 2, 3. If you count from right to left, then also it falls under 2, 3. Okay, that means here is 2 methyl. One methyl is at second position, another methyl is at where, third position. So 2, 3. Since there is 2 methyl, dimethyl. Okay, in a parent chain, how many carbon is there? 1, 2, 3, 4. So butane. Okay, so next, can we draw more? Let me check. Yes, we can draw. You see, if I arrange the carbon, let me rub this one. Okay, if I arrange the carbon in this way, suppose 4 carbon is there, so one here I will put, 1 carbon I will put here. This is also branch. This is the now methyl, this is the now part methyl. Now this 2 methyl is at what, second position of, in a, I mean in a carbon chain. This is the number 1, 2, 3, 4, because always I have to choose the lowest one. If I count from right to left, 1, 2, 3, that means both the methyl will be in third position of a carbon chain. So always we'll select the lowest one. So here 1 methyl is at where, in which position? Second position, comma. Another methyl is also at what position? Second position. So 2, 2. Since there is 2 methyl, so dimethyl. Now you count the carbon in a parent chain. 1, 2, 3, 4. So it will be what? Butane. Okay, that means from what? Hexane. Okay, we can draw the 5 structural isomer. Number first, what I have drawn N-hexane. Next will be 2-methylpentane, 3-methylpentane. Again 2,2 dimethyl butane. Again one is what? 2, 3 what? Butane. I mean dimethyl butane. Okay. So heptane, you check it in your homework. Heptane. This is your homework. Okay. So for today this much. Thank you.